Hello, welcome to this video. This is 4-3 and we are talking about concavity and points of inflection. The second video in this lesson is going to focus on the second derivative test, and we'll talk about how we kind of apply that. Foundationally, what we're going to talk about right now is concavity, and maybe your teachers before have talked about this, but kind of it's just the shape of a graph, and we'll kind of give you a non-mathematical memory device to help you kind of remember concavity. So let's go ahead and talk about concavity. Concavity, a graph is concave up if the tangent line lies below the graph. And what I mean by that, for an example here, notice I have a graph that is facing upwards. So this is concave up. Now I have a horizontal tangent line here at the bottom. Okay, and if I move this direction, okay, the slopes of the graph are increasing. Okay, and so if we look at the second derivative of this function, it's going to be greater than 0. Greater than 0. Okay, concave down. Here's a graph. It's concave down, right? It's facing downwards, and this has tangent lines, okay, that are below the horizontal tangent line. Okay, so relative to my horizontal tangent line, as I go this way, my slope values are decreasing, or they are negative. Okay, so f double prime will be less than or equal to 0. Okay, and just a general way how you can memorize concave up or concave down is by a smiley face, right? So if it's concave up, okay, your slope is positive. It's facing up. And if it's concave down, I'm facing down, right? How many chins do I have? That's concave up, right? Okay, so if you're feeling down, you're sad, right? That's concave down. If you're feeling happy, you're feeling elated, you're up, okay? So that's concave up and concave down. Okay, enough of my face. That was kind of scary. Now let's talk about inflection points. A point of inflection is where our graph changes from concave up to concave down. Okay, and it's important that there must be a tangent line there. Okay, so you cannot have an inflection point at a sharp turn. Okay, so here's an inflection point, and it's an inflection point if it has a tangent line. Okay, and it changes concavity. All right, so if we look at an example here, okay, I have concave up. Okay, for this portion of the graph, right? It's facing up. Smiley face, there's concave up. And then I have a concave down portion of the graph here. It's facing downwards. It's sad. Okay, and then right in the middle, we change right here. Okay, this is called a point of inflection, 0, 0. All right, so let's go ahead and look at some examples. And here this says, use the graph at the right to answer these questions. Base your answers on appearances of the graph. So it says, on which intervals is the graph concave upwards? And I'll use green. I want to know, okay, where is the graph happy? Where is it facing upwards? And right about here, right? It's facing upwards, okay? And also here on this interval, it's facing upwards. That's concave up. Okay, so that is going to be from 1 to 3 and 4 to 5. Okay. Oh, I forgot this beginning piece too here. It's also concave up here. Okay, and that would be -2 to -1. Okay, on which intervals is the graph concave down? Is it down? Well, whoa, not there. Where'd we go? Okay, here we go. All right, and 4 to 5. Okay, on which intervals is the graph concave down? Well, the graph is concave down this portion here, and that goes from -1 to 1, -1 to 1, okay? And also here, it's facing downwards. And that goes from 5 to 6. Okay? All right. On which intervals does the graph have no concavity? And this occurs when our graph is a straight line. And I'll go ahead, I'll do this in purple. Okay, so notice I have a straight line here, right? There's no concavity. That goes from 3 to 4. Okay, and there's another piece hiding right down here. It's a flat line there. Okay, so 6 to 7. All right. And then, okay, it says where are or what are the points of inflection? So remember that in order to be a point of inflection, we have to change from concave up or concave down, or vice versa. Okay, and then we also have to be differentiable. So notice we change inflection points here, right, from concave up to concave down. Okay, so that would be 1, -1, 1, -1, 1. Okay, and right here, okay, that would be 1, 1. Okay, and notice right here at this piece here, and this piece here, I'm not switching from concave up to concave down. It's a straight line, so there's no concavity there. And then also for the second one, notice that's a sharp turn. Okay, so those two examples are not inflection points. However, we do have one here at 5, 1. All right. Okay, so that is concavity, concave up, concave down, and that's how we look at this visually. What we're going to do next is we're going to look at how to identify inflection points and discuss concavity analytically, which just means we're doing some math in order to find these values. Okay, so how we do this is we're going to use the second derivative test, and the procedure is exactly the same for what we did with the first derivative test in finding increasing and decreasing. We're going to take the double derivative, we're going to analyze the critical numbers, and then do a sign analysis to figure out, okay, where is it positive, where is it negative, and that tells us concave up, concave down. All right, so here is our first example. Let me switch back to a normal color. Okay, determine the points of inflection and discuss concavity for the graph of f of x. Well, I want to talk about inflection and concavity, I need the second derivative. So f prime of x is 4x cubed plus 3x squared minus 6x. Okay, and now I want the second derivative, so f double prime of x, that is 12x squared plus 6x minus 6. Whoa. Minus 6. Really doesn't want to be that zoomed in. Wow. Okay, so now I'll go ahead and I'll set it equal to 0. Okay, so I'm going to take my function, set it equal to 0, and I'll factor out a 6. So we get 2x squared plus x minus 1, which is 2x minus 1, x plus 1. Okay, giving us 0 values of 1/2 and -1. Okay, so what these are possible points of inflection. Okay, so possible inflection points. Possible points of inflection. And my Estes abbreviates these as PPI, the PPI. Okay, so my PPI here is my sine graph for f double prime. And what I want to do is I want to test, or I want to do sign analysis for these values. Okay, so I have positive 1/2. So this is going to be -1. Here's positive 1/2. And I'm going to test some values. Okay, I only care about the sign values, so I can make life easy on me. I can pick good numbers, or rather large numbers that make my computations easy. I'll pick -100. If I plug in -100 over here, we're going to get a negative times a negative, which makes this positive. And in the middle, we'll test 0. If I plug in 0, we get a negative times a positive, which makes this negative. And then if we plug in 1, I get a positive times a positive, which makes this positive. Okay, so again, I'm taking these values and I'm plugging them into my f double prime to say, okay, is it positive or is it negative? All right. So okay. So what does that tell us? Well, it tells us that our graph is concave up on -infinity to -1 union 1 to infinity. Okay. And it's concave down on -1 to positive 1/2. Okay, the other part of this is they want us to discuss not only concavity, but they want us to discuss the points of inflection. Okay, so points of inflection. So I have critical numbers, right? And remember, points of inflection occur when we change from concave up to concave down, and that occurs at these two values here. Okay, so here's our possible points of inflection. And what we're going to do is, since they do change, right, from positive to negative, I know they are inflection points. So what we'll do is we will take them and we'll plug them into, not that function, we're going to plug them into our original function, f of x. Okay, so I'll plug in f of -1, okay, and we get -2 out. And then I'll plug in f of 1/2, and you get 7 over 16. Okay, so these are your points of inflection. So points of inflection at -1, -2, and 1/2, 7 over 16. All right. Okay. Let's go ahead. Let's look at a second example here. And it says if f of x and f double prime of x are these functions, list the intervals. Whoa, the lights turned out. Wow. Magic. And they're back on, just like that. Okay. So if those are the functions, list intervals where it's concave up, concave down, and we list the points of inflection. So, I mean, they already gave us our f double prime. They said f double prime is this function. Okay, and that's nice, because then we don't have to do anything. So it's already given to us, x squared minus 4 cubed. Okay, and I want to know, where is this function equal to 0? Okay, I want to find the critical values, and I can do some sign analysis. So we get 10 times 3x squared plus 4, which just gives us 3x squared plus 4. And at this point, you're like, this doesn't make sense. That's because it doesn't. This can never happen, right? So that means that your function never equals 0. Okay, so do you have no points of inflection. Okay, now what we can do, though, however, to test concavity is we are going to look at, okay, where is this function undefined, or where are our domain restrictions, okay? And our domain restrictions, okay, x cannot be plus or minus 2, right? And that comes from our function here, okay? So cannot be plus or minus 2, and what's occurring there is that we have vertical asymptotes. So I'll go ahead, I'll draw f double prime, and I'm going to plug in these asymptotes, okay? So I have -2, we have +2, okay? And we're going to go ahead and we're going to plug in some values. Okay, so let's plug in, again, I'll choose -100. Here I'll plug in 0 and +100. Okay, and if I plug these in, okay, so I'll plug them into f double prime here, and we get a positive over a positive, so this is positive. Plug in 0. 0 gives me a positive over a negative cubed, still negative, so positive or negative, that's negative. And then I'll plug in 100, and that will give us a positive over a positive, so this is also positive. Okay, so what does that mean? Well, it means that our graph is concave up on -infinity to -2, union 2 to infinity, and it is concave down on -2 to 2. Okay, and also, again, no points of inflection. All right, that is it for this video. In this video, we talked about concave up, concave down, and then points of inflection, right, in between. Alrighty, so watch the next video. We're going to talk about how to apply the second derivative test. Peace.